China's ongoing work on what is widely referred to as the Type 004 aircraft carrier represents one of the most significant and ambitious undertakings in its modern naval history. This vessel, expected to be the country's first nuclear-powered carrier, is not simply another ship in the fleet. It is the culmination of decades of gradual industrial buildup, technological experimentation, and strategic vision. Its construction reflects how China's national defense priorities have evolved alongside its economic rise and global integration. The process leading to this carrier did not emerge from a single decision but from an accumulated sequence of smaller achievements that have reshaped China's maritime strategy from coastal defense to global reach. For most of the 20th century, China's navy operated as a near-shore force focused on territorial protection and the defense of vital sea approaches. This orientation made sense for a country that had not yet achieved major industrial or logistical capacity. Its early vessels were largely imported or based on Soviet designs, built for operations close to home ports. As the nation's economy opened and its trade routes expanded across continents, Chinese strategists began to realize that such a defensive model was inadequate. The seas were no longer barriers, they had become highways carrying raw materials and finished goods that sustained the nation's growth. Ensuring their security required a navy that could act at long distances and for extended durations. The development of aircraft carriers became the natural solution, and over time, nuclear propulsion appeared as the ultimate enabler of true global endurance. The progression from the first carrier to the one now under development tells a clear story of learning and confidence. The Liaoning, acquired as an unfinished Soviet hull in the 1990s, was transformed into a functioning carrier through years of reverse engineering and experimentation. It provided China with essential experience in flight operations, deck management, and coordination between naval aviation and surface ships. The Shandong, built domestically, confirmed that Chinese industry could not only replicate but also improve upon the earlier design. The third carrier, Fujian, introduced electromagnetic launch systems and a far more advanced power distribution network. That vessel marked the point at which China's carriers began to diverge significantly from older models and started to reflect independent engineering choices. Having demonstrated the ability to build such complex ships, China's shipbuilders gained the confidence to pursue the next logical step: nuclear propulsion. Nuclear power for surface vessels is not new in theory, but achieving it requires an exceptional combination of expertise in reactor design, materials science, electrical engineering, and ship integration. The key challenge lies in safely transferring the enormous energy produced by a reactor into usable propulsion and electrical output without compromising safety or efficiency. Chinese engineers have drawn on their long experience operating nuclear-powered submarines to tackle these problems. For decades, those submarines have provided training grounds for specialists in reactor operation, maintenance, and safety procedures. The knowledge from that field, though focused on smaller platforms, can be scaled up with sufficient research and investment. The gradual construction of dedicated testing facilities and training reactors indicates that this process has been underway quietly for years. From a strategic perspective, the pursuit of a nuclear carrier aligns with China's broader objective of extending its reach into what it calls the far seas. Conventional carriers, even large ones, remain dependent on refueling ships or friendly ports to maintain extended deployments. This limitation restricts the operational tempo and geographical flexibility of the fleet. A nuclear-powered carrier removes these constraints. It can travel for years without refueling, limited mainly by food supplies and aviation fuel. It also allows greater freedom of movement in crisis situations, when supply lines might be disrupted. For a country with expanding global interests, the ability to keep a powerful naval presence on station indefinitely represents both a deterrent and a reassurance to its partners and citizens abroad. Another aspect of this development lies in the immense industrial and organizational effort that such a ship demands. Building a nuclear-powered aircraft carrier requires more than technical blueprints. It demands a vast ecosystem of specialized manufacturing, precision engineering, and quality control that touches nearly every branch of heavy industry. The materials used for reactor containment, for instance, must withstand extreme heat and pressure while remaining stable over decades of operation. The propulsion turbines and electrical systems must operate seamlessly with the ship's electronic command networks. Every part of the vessel, from the hull structure to the sensors, must be built to exacting tolerances. Achieving that level of integration reflects a national industrial capability that few countries possess. In this sense, the Type 004 serves as a demonstration of China's ability to organize complex, high-risk, high-value projects across multiple sectors. Within China's naval planning circles, the move to nuclear power is also viewed as a step toward greater independence from foreign technology. Earlier carriers, while mostly domestic in construction, still relied on components or design elements inspired by other nations. The new vessel, by contrast, is expected to embody a nearly complete supply chain sourced from within China. Domestic reactor design, indigenous steel alloys, and Chinese-developed electronics and sensors form the backbone of the project. This shift not only ensures security of supply but also showcases technological sovereignty, an important theme in Chinese strategic thinking. The government sees major defense projects as instruments of both security and national pride, emphasizing the ability to build everything from the ground up without relying on external partners. Operationally, a nuclear-powered carrier changes the nature of naval deployment. It allows a task group to maintain presence in key regions for years, rotating crews and aircraft while the ship itself remains on station. This endurance capability would enable China to participate more actively in humanitarian relief, peacekeeping, and anti-piracy missions far from its home ports. It also provides a platform for joint exercises with other navies, supporting diplomatic outreach and influence. For the People's Liberation Army Navy, which has steadily increased its participation in international operations, such a ship represents both a tool of statecraft and an anchor of global presence. The development of the Type 004 also carries internal training and organizational implications. Carrier operations require not only advanced technology but also a deep culture of precision and coordination. Every takeoff and landing depends on hundreds of interconnected tasks, from deck handling and fueling to air traffic control and engineering maintenance. The plan has spent years cultivating this expertise, training successive generations of pilots, deck crews, and technicians. A nuclear carrier adds another layer of complexity: reactor specialists, radiation safety officers, and engineers who must manage and monitor the ship's power systems around the clock. Establishing this workforce will take time and sustained investment, but it ensures that by the time the ship enters full service, the personnel will be ready to operate it safely and effectively. The scale of the Type 004 suggests that it will likely approach or even exceed 100,000 tons in displacement, comparable to the world's largest carriers. Its deck arrangement is expected to support multiple simultaneous launch and recovery operations using electromagnetic catapults. The air wing is likely to include stealth fighters, early warning aircraft, electronic warfare planes, and uncrewed aerial vehicles. This combination reflects a clear intent to integrate advanced aviation technology and to diversify operational capabilities. With such a composition, the carrier could perform multiple roles: air superiority, surveillance, electronic warfare, and strike operations, without relying on land-based support. This self-sufficiency reinforces the purpose of nuclear propulsion: complete autonomy in distant waters. Despite its advantages, building and operating a nuclear-powered carrier will not be without difficulties. The safety standards required for nuclear systems are extremely high. Even minor accidents could have serious environmental and political consequences. China will need to develop robust maintenance and oversight systems, train specialized inspection teams, and ensure transparency and safety protocols to meet international expectations. The logistical chain for handling reactor maintenance, refueling, and eventual decommissioning must be carefully planned decades in advance. Such long-term commitments demonstrate that nuclear propulsion is not merely a technological achievement but also an institutional one, requiring sustained discipline and coordination across generations. Beyond its military function, the Type 004 also serves as a message about China's broader aspirations. It signals that the country intends to remain a permanent maritime presence on the global stage. In practical terms, this means China will have the ability to project power, support allies, and safeguard its interests anywhere on the planet. Symbolically, it places China in the small circle of nations, currently the United States and France, that operate nuclear-powered carriers, a mark of advanced industrial and strategic capability. It is not simply a matter of matching another country's fleet but of demonstrating that China can meet the technical, economic, and organizational standards required to build such ships on its own. The existence of the Type 004 project also affects how other countries perceive the regional balance of power. It represents the next phase in an arms dynamic that has gradually extended from coastal defenses to global force projection. Other nations will need to account for a future in which Chinese carrier strike groups can operate for months or years in distant waters. This does not necessarily mean confrontation. It could also lead to new forms of naval diplomacy, joint exercises, and cooperative security missions. However, the presence of a nuclear-powered Chinese carrier will undoubtedly influence strategic calculations across the Indo-Pacific and beyond. Within China, the carrier program has also become a symbol of national achievement. The scale of the effort, the complexity of the technology, and the coordination required across multiple industries mirror the country's broader transformation from an industrial follower to an innovation leader. The government's emphasis on scientific advancement and self-reliance finds a tangible expression in such projects. Universities, state-owned enterprises, and research institutions contribute to solving the thousands of technical challenges associated with the carrier's design and operation. This mobilization of knowledge and talent demonstrates how defense and civilian industries reinforce one another, with breakthroughs in materials, computing, and automation benefiting both sectors. The development of China's first nuclear-powered carrier represents far more than the construction of a single warship. It encapsulates a national transition, a shift from regional defense to global engagement, from imitation to innovation, and from reliance on external technology to self-sustained capability. Even before the ship enters service, it is already fulfilling its purpose as a catalyst for technological growth and strategic transformation. Over time, as training matures, systems stabilize, and experience accumulates, the lessons drawn from this project will inform the next generation of carriers and surface combatants. These future vessels will likely incorporate improved reactors, modular construction techniques, and even greater automation, further extending the plan's ability to operate across the world's oceans. The Type 004 stands as both a symbol and a tool of China's maritime future. It is a reflection of a long-term vision in which national power, technological mastery, and strategic reach are inseparable. By pursuing nuclear propulsion, China is not merely seeking parity with established naval powers but laying the foundation for independent, sustained global operations that could redefine its role in international security. The completion and eventual deployment of this carrier will mark a turning point, signifying that the country has entered a new era of naval capability, one that combines endurance, innovation, and strategic purpose in a single platform that embodies decades of accumulated effort.